Welcome to today's webinar, Getting Started with the AWS IoT and Dragon IoT Starter Kit. Our presenter today is John Rota. He's a software development engineer at AWS. We also have Lisu Zheng, software development engineer, Gary Wicker, software development engineer, and Rong Cheng, software development engineer, as our webinar moderators. They will be engaging with you and answering your questions throughout the presentation while our presenter presents. John, welcome. The floor is now yours.
Thanks, Ryan. As you said, I'm John Rota. I'm a software engineer on AWS IoT, and I'm going to guide you through getting started with AWS IoT. The presentation today is going to have three parts. The first is going to be, I'm going to talk through the service and the components of the service, walking through a slide presentation. The second part, I'm actually going to build in the webinar. I'm going to build through a screen share an AWS IoT use case. I've got a use case that we're going to walk through. We're actually going to build it live in the webinar. And then the third part, I'm going to show a video of a device actually running this in our lab. So what is AWS IoT? Our landing page says AWS IoT is a managed cloud platform that lets connected devices easily and securely interact with cloud applications and other AWS services. The service can support billions of devices and trillions of messages and can process and route those messages securely and reliably. On the slide, you'll see various components of AWS IoT, and through the following slides, I'm going to walk through and touch on each of these and let you know what their purpose is and how to use them in your applications. So first, let's talk about security and identity of the service. There's three things I want to highlight for this, and they are authentication, and then fine-grained authorization, and then end-to-end encryption. So let's talk about authentication. For devices, we're handling that through TLS mutual auth. So the device will present a client certificate to the service, and that's the device's identity. We also have WebSocket authentication. So for web apps and mobile apps, you can authenticate using SigV4 and create a WebSocket connection. And it's important when we move to fine-grained authorization, it's important to note that if each device can have its own identity, then you can assign permissions to each device, and those can be scoped down to only what that device needs to do. And so it makes a lot of sense where a device probably only needs to connect and maybe publish to its topic or update its own shadow, and it doesn't need to have permissions to delete things and manipulate other things in your account. And that's important because if those credentials were ever compromised, you want to limit what that device can do. And if you can give a certificate to each device, that allows you to scope permissions to each and every device. And then I mentioned end-to-end security or end-to-end encryption, and we're doing that through TLS 1.2, and we've only enabled the most strong cipher suites for TLS 1.2, and so you can be assured that that connection is secure. There's no tampering or eavesdropping. Another thing I'll bring up here, something we recently launched, was support for ECC keys, so elliptical curve keys. And what that allows is for the same key strength, but less computational power required on a device, so that's an important use case for IoT. One note I want to bring up is this is just standard web-based security, so X509 certificates, TLS, that's all stuff that is standard web security, and we just applied it to IoT. It's nothing proprietary that we invented. The next component is the device gateway, and this is, you can think of this as the front end for your device. This is what actually handles those long-lived connections. And this is where the component that allows us to scale to those billions of connections. Inside the device gateway is a mechanism that handles those connections, and it handles MQTT or HTTP connections. Brokering messages, there's a message broker inside of the gateway that handles routing those messages, whether it be to other devices or to the rules engine. And inside of that is a topic-based architecture. So the MQTT protocol is a pub-sub architecture. And so what that means is when clients connect, they can subscribe to message topics and decide what messages they want to see. And other clients will publish to those message topics. And I bring that up, you can see at the bottom of the slide, there's, I say topic-based architecture, and I kind of have an example of a way you could design your topic space. In your account, those topics are wide open to you, so you can design your topic architecture, how it makes most sense for your system. And I just call out a little simple example there of, let's say we have a campus of buildings, and each building has different equipment that we're managing. And so you can see I've architected it in a hierarchy of buildings, and then the equipment under those buildings, and then each individual unit. And what that allows us to do is address down to the unit. So I could talk to specifically just unit number 5, or I could even broadcast messages or subscribe to all the chillers or all the packing machines. And so that topic space is wide open. You can use it to design it for your system. The device registry is a way to help you manage your devices. It allows you to tag metadata to those devices, and so you can keep them organized. Here's an example of some data that could be in the device registry. On the upper left is me doing an AWS CLI call and getting that data from a device I've called Pump1. And you can see I have tagged that device with things like model number and the install date. And in the lower right is us exposing that information through the AWS IoT console. One use case we saw that was a kind of cool use for this was someone put the URL to a service manual to their device in this data, and then when there was a trouble with that device, their application was able to just query that device's registry and grab that URL, and then present that service manual to the technician. Device shadow, you can think of a device shadow as a copy of the device in the cloud. And where that becomes powerful is if you're an application developer developing against your devices, you no longer have to worry about the connection state of that device. Is it connected? Can I send it a message? You're just interacting with a cloud copy of that device. And so that API is always present. You always can interact with it, do things like get the last known value or update, send an update of state to that. And if the device is online, that message gets to the device immediately. And if it's offline, the next time it comes online, that sync happens. So it disconnects the programming against the device with whether it's connected or not. A device shadow has a state document. This is how we define the state that's in the cloud. There's 3 sections of that document: desired, reported, and delta. Reported, you can see that in the red. That's what we consider to be the values coming from the device. So when the device is saying the current temperature is 30 degrees or my current set point is 5 pounds, that's what the device reports. The desired section is your cloud application. When it wants to change a set point or it wants to send a command, it would manipulate the desired section of the document. And then you can see the delta, that's our shadow service computing a difference between the two. So if the device reported that its current state was off and you commanded it to be on through desired, we would generate a delta that says that the device should be on, just the difference between the desired and reported. And so I've got a little example I can walk through to make that a little more clear. One of the great features of this is you can see the state document over there on the right. This could be up to 8K in length, so there could be many keys and values in there. And through the delta feature, we compute only the value that the device needs to be concerned about. So the device doesn't have to parse through this document and figure out one thing changed. The delta tells the device, here's exactly what the difference is. And so let's walk through a little use case. You can see the mobile app up in the left corner and then the device below it. And then you can see there's a cloud representation, a shadow of the device in the cloud. So we're going to say that the mobile app sends a command, it updates the desired state and says that engine should be on. And you can see the change in the state document. The last reported state of the device was off and the current desired is on. So you can see we have a delta down there that says the engine should be on. And so now the device comes online and it publishes and says, hey, my engine is currently off. And what happens is the shadow then publishes that sync message, that delta, back down to the device and says, no, actually the engine, since you were offline, the engine was commanded to be on. And you can notice that none of the other state document went down to the device. It's just what it needs to know, what it actually needs to act upon. And so in this case, we're going to say the engine turns on, the device turns the engine on, and then reports back, my reported state is on. And you can see the difference between these two is that then resolves the delta. and the state document is happy, it's in sync, and there's nothing left for the device to do. The rules engine is, I talked earlier about the AWS IoT service can route your messages and your data to other AWS services, and that's through integrations with our rules engine. Our rules engine operates on a really simple SQL syntax, so you can do things like in a familiar manner of, and you can see here's an example, select statement. You can do things like select messages from certain topics and then do actions upon them. And I've got a couple of examples here in the next slides of things you could do with the rules engine. In this case, we're going back to my example of a campus full of buildings and a lot of equipment under those buildings. And so what I'm saying here is, let's say we want to visualize all of the equipment in building number 1. And so I created a SQL statement that says select star, which is select all the messages, from building 1/pound. And what pound is in MQTT is a wildcard. So any messages that are under building 1, I want those to go to DynamoDB. And so that then we could create our visualization off of just building 1's data. You can also use the rules engine to select and pick the needles out of the haystack. So in this case, we're going to say we've got chillers that are in all of our buildings, and if the coolant level ever dropped below a certain value, we want to know about it. That's a bad thing. And so I constructed this to say select all the messages again from, when I say plus there, that's another MQTT wildcard, and it just matches one level topic. So I'm saying select from any of the buildings, if the middle thing is chillers, if the equipment type is chillers, and then any of the equipment that is a chiller. So just all of my chillers. If the coolant level is in that, and what coolant means in there is that's actually a payload value in the message. So if we see a message that has a coolant value that's less than 20, then we want to do an action upon that. And what I'm saying here is I want to run a Lambda and I want to do an SNS. And what I'm supposing for this would be is Lambda would be a good way to, if you have maybe a trouble ticketing system, you can just write some cloud code in a Lambda that would enter a ticket into your trouble ticket system. And then SNS is, as you know, is a messaging system, and that you could use that to push a push notification to a technician that says, hey, we've got a problem with this chiller. So a really powerful way to grab data in real time out of these streams. I'd mentioned the rules engine has a lot of integrations to other AWS services, and so here on the left is a list of those. Things like DynamoDB, Kinesis, I just want to route my data into data stores or streams I already have. Lambda is super powerful. As every event comes through the system, you can run a cloud function on it. Put data into S3. Elasticsearch is an integration we recently launched. It's an integration with AWS Elasticsearch service. If you know Elasticsearch, that's a great search engine database. You can do a lot of cool analytics stuff with it. CloudWatch, if you're familiar with CloudWatch in the alarming and metrics, you can route AWS IoT data into CloudWatch alarms so you can manipulate your alarms with IoT data. SNS is messaging. You can send messages, Firehose, data streams, push messages into SQS queues, and then republish is you maybe would want to act upon data and then send it to another device, and republish allows you to publish a message back into the broker from the rules engine. I'll highlight a couple transformations on the right. These are little functions you can run right in the rules engine on your data to maybe shape it or to pick things out of it. Things like round or trigonometry functions, so you can shape the data a little bit. The bottom two, client ID and topic tokens, those are ways to grab things out of metadata, like what client was connected when this message came through, what client sent that message. Or topic tokens, in our example with buildings, you could actually select that first part of the topic, so you could actually augment the message, the payload of the message, with that building number. Some cool things you can do in the rules engine as the messages go through. We've got a number of device SDKs that make connecting to the service easier. We have a C SDK, and that's the SDK you use on a more deeply embedded device, maybe a device like a microcontroller or a device running an RTOS. We've got a Node, a JavaScript SDK. That's a great experience for using on embedded Linux devices like a Raspberry Pi. Writing in Node, you still have access to the hardware, but it's a nice high-level language that's easy to get going with. We recently made an update to that SDK, so you can run it in a browser too, so you can do a WebSocket connection from a browser and make a real-time connection and get MQTT data in your browser. We have an Arduino Une SDK. You're probably familiar with the Arduino programming environment. Maybe you've made some things and you have some sketches. This is a great way to use the Arduino environment and connect natively to AWS IoT. And we've got Android and iOS mobile SDKs, and both of those support WebSocket connections, so you can get real-time data feeds to your mobile devices. And you can also do things like make control plane calls and manipulate rules and create certificates and things like that. So really powerful mobile SDKs as well. We've partnered with a number of hardware companies. If you think this stuff is really cool and you want to get started, you can go out and buy these on Amazon.com. And it's a great way to get hardware, and you get hardware that hardware partners have already taken the time to use our SDKs and test the connectivity with AWS IoT, so it's a great way to get started. I'm going to highlight 3 of those. In this example walkthrough, I'm going to use the Node.js SDK. And so these are 3 possible boards out of those that would be great for running this demo. All of them are embedded Linux. All of them have great support. The one I specifically picked for this was the Dragon Board 410C from Arrow and Qualcomm. This is a really powerful IoT solution. It gives you access to the hardware, but it's a great board to run things like if you need to push a display. Maybe you've got a touch screen like a kiosk or a digital signage thing. This would be a great board for that use case. So now we're going to go in and actually build out this use case. I'm going to talk a little bit first about the use case, and then we'll go to the screen share, and I'll be able to walk through building it out during the webinar. So this use case actually was something that came up in a customer meeting. We had talked to someone who was looking at using IoT in their business, and this person in a former life was an engineer, and he was really interested in trying this stuff out at home and just try to educate himself about IoT before trying to make a decision on what he was going to do for his business. And so the use case he presented was he has a pool in his backyard, and then there's a building, a pool house, that houses the pool pump. And he said he lived in a climate where occasionally he would have to go out and turn the pool pump on if it was getting cold outside, and he would run the pump overnight just to make sure the equipment didn't freeze or nothing happened to it. And his problem with this in just trying to send messages to this device that he had made was the internet connectivity in this pool house is pretty intermittent. And so he did have to kind of worry, is this device online? Okay, yes, it is online. Now I can send the message to turn the pump on. And so we talked about it, and it seemed like a great use case for the shadow, where he could just program against the shadow with this mobile app that he had made and then handle the syncing when the device came back online to turn the pump on. And one of the things he brought up, he was pretty astute about it. He said, it'd be nice, though, too, I can trust that sync happens, but I'd really like to know, I'd like a notification to come back to me and say, yes, that sync actually happened. And so what we did, here's an architecture of what this use case is going to be. You can see the device is talking to the shadow, and the application, in this case, in the walkthrough, it's going to be the AWS IoT console, but that's where you would have an API call from a browser or a mobile phone that also would manipulate the shadow. And when that sync happens, the device shadow emits an accepted message. It emits a message when that sync happens. And what we're going to do is tie a rule to that and look for that. And if that happens, when that sync happens and the pump comes on, then we're going to push a message into SNS, and we can get a push notification or an SMS message that tells you, yes, that sync happened. So let's switch over to the screen share, and we'll walk through building this out. All right, I'm going to go back to my console homepage just to give you an orientation of where we're at. I'm going to go into AWS IoT. And now you're going to see a list of all the resources I have. And the first thing I'm going to do for this use case is we're making a pump controller device. So I'm going to create a thing. So I just go to create a resource, create a thing. Let's just name it pump1. And here for attributes, when I talked about the device registry, this is a place where you can tag these attributes to that device. So let's go ahead and do that. I'm going to say things like, let's just say it's model number, maybe a serial number. And let's do install date too. And then we'll create that thing. You can see here it is. The next thing we're going to do for that to enable that device to be connected is we'll create a certificate for it. So I'll go back up here to my creation, click on create a certificate. Now there's a couple of options when you're creating certificates. You can upload a CSR, or for a getting started experience like this, it's really easy. You can just do a one-click create and we create everything for you and let you download it. I'm going to click this activate box, and what that means is when the service creates this certificate, it's just going to create it as active and ready to use right from the start. We'll go ahead and do that. And here I have download links for my certificate and private key, and so I'm going to go ahead and download those. Then I'm going to switch over to my workspace on my Mac. And it's important to note here, I'm using the Node.js SDK and I'm going to use it on my Mac. If you were developing on a device, as I did with the Dragon board, I just did this SSH into the device, and I could do, I could copy the certificates over, and I could run and build the SDK right through a terminal screen. But for this getting started, for building it in the webinar, I'm just going to be on my Mac. So you can see I get a directory set up already. The only thing in there is a directory for the certs. So let's move those, the private key and the certificate into that directory. And then the next step, what I'm going to do is, in order for the device to verify the identity of AWS IoT, when the device connects to the service, AWS IoT is going to present a certificate, a server certificate to the device. And what it needs to do is verify that AWS IoT is actually AWS IoT. And it's going to do that through a root CA certificate. Now, typically a browser or another internet app, it's going to have a list of these well-known certificate authorities built into the app. But those consume space. So in an IoT device, you're going to want to find the specific CA that you're going to verify the service you're connecting to. And so the way we get that for AWS IoT is we'll go to our developer docs. And under security and authentication, we've got a link to the root CA you want to use with AWS IoT. So I'm going to go ahead and save it. And we'll stick it right in that same certs directory. Now if we go into certs, we'll see everything we had in there. And what I'm going to do now is I'm going to rename these to smaller names just to give them an easier name to work with when I'm working through this walkthrough. So let's name the certificate just cert, name the private key just key. Now let's rename our root CA certificate. Let's just name that root. There we go. So now that I have the certificates created, the next thing I need to do, I talked about once you have this identity, that allows you to attach permissions to each device. And so what I need to do is, a certificate by default has no permissions. And so what we need to do is create a policy that defines what that device is allowed to do and attach it to that certificate. So I'm going to go back into the console and say create a policy. And we'll just name it pump policy. If I just start typing I, you can see all the IoT actions that are allowed that you can specify in a policy. And so a typical use case, you would do something like this device is allowed to connect and then publish to a certain topic. And you can see the field resource, that's where you would specify the topic. For this walkthrough, I'm gonna have it more open just so it's easy to get going. But in the future, as I built out this use case, I would scope this back down to say this is exactly what that device is allowed to do. Now that we created that policy, we're going to go into our certificate. And there's two things we're going to do now. The first is I'm going to attach this. I'm going to attach this certificate to my thing. And that doesn't add any specific functionality other than now when I'm looking at my things, if I see here's my list of certificates, I can go through those and see this certificate belongs with this thing. This is why I need to keep this certificate around. This is why I need specific permissions on it. It's just a bookkeeping way of keeping track of where that certificate belongs. And the more important thing too, also while I have the certificate selected, is we're going to attach that policy we just created. So I go in and I say my pump policy, and let's attach that to that certificate. Okay. So if we go back to that certificate, we can see it's attached to our thing and a policy's been attached to it. And so now we should have everything we need to use the certificate, connect to the service, and publish messages. So let's test that out and make sure that's the case. And the way I'm going to do that is using a test program called MQTT-FX. And all this is a GUI-based MQTT client that we can use to connect. And let's just make sure everything's set up correctly before we move to start doing it on a device. It's just easier to debug from this platform before we start getting into actually running it on a device. So in this client, it's important to note there's other MQTT test clients. Mosquito's a good one. There's other ways that you can use, other clients you can use. This just happens to be a good one that shows well for a webinar. So I've got a connection profile. I've already started this. I've called my profile webinar. I need to put in a broker address. Where is this actually going to connect? And the way we find that out is if we go back to our console page, up here at the top is a question mark. And if I click on that, you can see here is the endpoint for my account. This is my IoT endpoint. We're going to grab that and go back to our test client and just paste that in. For port, we're going to use 8883. That's the well-known port for secure MQTT. And I'm just going to name this, give this client ID, just pick something, webinar client. At this point, it's important to bring out a common getting started mistake is your client IDs for MQTT need to be unique across your account. The MQTT spec says that if a client ID connects and it's a duplicate, that the broker is actually supposed to disconnect the previous connection. And so just an important thing to note is those need to be unique. I'm going to leave these at default, and we're going to go over here to configure TLS. I'm going to say enable that. You can see TLS 1.2 is already highlighted. And I'm going to click on the option for self-signed certificates. And what that does, it just allows us to specify a specific root CA file. And so now I'm going to go over here. Let's get the directory where I put those certs. That and copy it so it's easy. My root CA, I just called root CA. My certificate was cert. And my private key was just key. These are PEM formatted certificates, so I'm going to click that. Say apply. And we should be good to go. So now we can connect. Now we should test and see if we have everything set up correctly. You can see the little green arrow came on, the lock is locked, we connected with the TLS connection, and now we're connected to the broker using that certificate. So this verifies we attached a policy correctly, the cert is active. A lot of common problems in getting started, so we verified that we've done that correctly. So now what I'm going to do, I'm going to highlight another feature we have in our console, we have an MQTT test client. So let's go ahead and click on that. Let's go ahead and generate a random client ID and connect. So this is another great way to test. It's not actually testing our certificate setup, but it's a good way if you need a quick MQTT client to the service, it's built into the console. I'm going to subscribe to a topic. Just click subscribe. Let's go back over to our test client and publish to that topic. We should see, drag this out of the way a little bit. We'll see we got our message. These two clients are talking to each other through the service. That's just a good way to verify that everything was set up. One other thing I want to highlight while we're here, if we go back to our developer docs, we recently launched a feature called lifecycle events. And what that allows you to do as your devices go through their life cycle of connecting and publishing, we publish events that this metadata around those. And so I wanted to show that really quickly just as a powerful way to debug and keep tabs on like the status of your devices. So let's go ahead and subscribe to this topic. I'm going to get rid of connected and just put a wildcard there. I want all of the events. And then I'm going to put the client ID of my test client in there, and I'm going to subscribe. So now if we go back to our test client and we disconnect, you can see a message came in, and we're going to connect again. You can see we can get those connection and disconnect events by subscribing to this lifecycle event topic. And so it's just, again, it's a cool way to get metadata about your devices, see their connection status, maybe debug. If you're writing your own client, you can see if it gets connected by subscribing to that topic. So just a cool feature. So now we're to the point where we've got our certificate created, we've got a policy on it, we verified that it works. So now what we're going to do is get this working in an SDK. So what I'm going to do is I'm going to go to, this is the GitHub page for our Node.js SDK. I'm going to click on the clone link and copy it. Let's just go back to our workspace here, and let's clone that. And it's a Node.js SDK, so we're going to do an npm install to install our dependencies. And after this install happens, I'll walk you through the directory structure a bit, and then we'll build out the application. And I've gone ahead and created an example file already that I'll just copy in, and we'll walk through that and show the parts that you need to be concerned with, how we respond to those delta events, what we do upon a connect to make this flow, this shadow flow, work. And then after that, I'll walk through how we connect, how we create a rule on that accepted topic. And I'll actually end up pushing a SMS to my phone. So now that that install happened, you can see the directory structure. There's an examples directory. Let's see what's in there. In there, we have a couple examples, a pub sub example and some shadow examples. The browser example, if you're going to create a JavaScript package and actually use this in a browser, we have that in there. And I'm just going to go ahead and copy. I've got that file I already created. I'm just going to go ahead and copy that into the examples. Now let's take a look at that. So you can see I'm configuring to use the cert I just created, private key insert in root CA. When I wrote this to be run on the Dragon board, I actually used here, you can see that it's commented out now, but that's how I got access to the GPIO, so I could read what the current state was or set the state, turn the device on and off. If we go down, what I'm showing here is when we connect the things that we want to do, and you can see right here, I'm registering this thing, this pump 1, and what that does, it tells the service that I'm interested in those delta events from that. And then down here is on a delta. When we do get that delta message, here's what we do. And basically what we do is if we get a mode that says we should be on, we change it to on, and you can see I'm setting it to on, and then likewise off, we set it to off. So let's give this a try. And what I've done, I'm not running on a device with GPIO, so I have a command parameter that says, what should that state be when I start up? So I'm going to run that. It's going to start up, connects to the service, and then it publishes to the service that the reported mode that I'm in is off. So let's go take a look at our thing. We'll look at pump 1, and you can see the shadow state for that is the pump is off. And so let's manipulate that while we're here. We'll go in. Let's say desired for that, let's say that's on. And we'll go ahead and do that update. Over here in our device window, you can see we got that delta message. We set the device to on. Because we're connected, we're getting those messages instantly. So let's go ahead, we can do that again. Here you can see now it's in sync because the device reported back, turned itself on. Let's try this again, turn it off. You can see again, we responded, we turned the device off, reported back to the service and said we're off. So if we refresh our state here, we're off. Here is where this becomes a little more powerful. I'll disconnect the device. Then I can go back in here, do that same update. Update it. You can see nothing happens over in the device window. It's not connected. That program isn't running. And you can see this delta is still staying there. There's nothing connected to resolve it. But then if I go back over here and connect, publish that I'm off, that's when this device will get that delta message when it came back online, and it realizes that that delta said it was supposed to be on, so it turned itself on. Back here you can see that we're in sync, that delta has been resolved. And so now we've gone through that use case. I'm going to ask, well, what about that functionality where we get a message when that happens? So let's really quickly, let's create a rule on that accepted topic so we can see that happen. Do is update this to be off. Okay, so now we go create a resource and we're going to create a rule. And I have the rule syntax I'm going to use here, convenient, so I can just copy and paste it. I'll paste this in and then we'll walk through what exactly that's doing. So let's just call this the rule pump on. And I'll finish pasting this in and then we can talk through what exactly this is going to do. The action, so when this rule happens, what do we want to have happen? We're going to say SNS. I've already got an SNS topic set up that goes to my phone. I've got a role. This will walk you through creating these things if they aren't created already. Add that action and we'll create that rule. So now let's look and see what was it that I pasted in that's going to do this work. So what I'm saying is, if you remember back in our device window, we're reporting state reported pump mode, and that's on. And so what I'm going to do is look for whenever state reported pump mode is on, you can see where it's on, from this accepted topic. And so whenever that happens, whenever the shadow emits that message and it accepts that the pump is on, this rule is going to run. So let's go back into our thing. Pump 1. I'm going to do that update again. I'm going to do that update. You can see that sync went down to the device. It acknowledged it. And now if we go and take a look at my phone, I got a message just now that said that sync happened. And so there it is. We built out that use case during the webinar, and now I'm going to go and show the video of this actually running on a device. And this is running on that Dragon Board 410C that we had that I talked to earlier. And so now what you can see is the Dragon Board's down there in the front, and it's connected to a relay, and that relay is connected to a lamp in the background, and that'll be a good visualization that this happens. And you can see that monitor toward the back is me on that device, and I'm starting up that same program that we just watched, and it comes up, the lamp is off, so it reports to the service that it's off. And then I'm going to go over here in the console, and I'm going to do that same manipulation. I'm going to change that state to be on. And we'll see, since that device is connected, it's going to get that update right away. So now I changed desired to be on. I'm going to go down and click the button. And you can see almost instantly that lamp turned on. And we're going to go back, and you can see I'm going to turn that lamp off. Again, click the Update Shadow button, and the lamp goes off. And so just a little bit more into the video, we're going to do, I'm going to show that same use case. I'm going to stop the device, update the shadow, and then you'll see that sync happen. So here I had stopped it. We're going to go in and manipulate the shadow while it's offline. And you can see that since it's offline, that's delta message isn't processed by the device. The shadow state of that device in the cloud is still sitting there with an unresolved delta. And so when I start the device back up, it's going to report that the lamp is off, and then that sync's going to happen. So that was just a use case, a walkthrough of that use case on a device, so you could see it actually controlling something in the physical world. And so there you have it. We built this use case in the time of this webinar. You got a good overview of all of these features. So questions after the webinar ends, we're going to go into a live Q&A session here pretty soon. But afterwards, if you have questions, here's some web information. Of particular interest is the AWS IoT forum. That forum is watched by engineers such as me and the moderators here in the room. And so it's a great way of getting access to actual AWS IoT engineers if you have problems getting started, if you have specific questions, feature requests. That's a great resource.